Evaluate the integral of 1 upon x minus x cube with respect to x. With reference to these various types, let's now try to integrate this new function. Here the integrand is in the form of a polynomial upon polynomial, which is called a rational function. When the integrand is a rational function, we have to apply partial fractions. But partial fractions are applicable only if the denominator polynomial is written in the form of factors, not only just having px upon qx, polynomial upon polynomial. So we need to modify this integrand. Trying to factorize, first of all I'm taking x common, and the factor 1 minus x square can again be factorized into 1 minus x into 1 plus x. Now the denominator, the third degree polynomial, is written in the form of factors. 3 first degree factors, linear factors. Now let's see which type of partial fraction will be suitable for this. When the denominator is linear distinct factors, then the pattern is this. Each of the linear factors are written as the denominator with 3 different constants. Let's try to write it in that form. So let this integrand be in the form a upon first factor x plus b upon second factor 1 minus x plus c upon 1 plus x, if possible. Is it possible to write so? Yet to see. Let's try to find the values of a, b and c. For that, I'll first simplify the RHS. Taking LCM, x into 1 minus x into 1 plus x will be the denominator LCM, which will be the same here, which will cancel from both sides. So during the LCM process, the numerator then will be a into these two factors plus b into first factor and third factor plus c into these two factors. That is 1 equal to, why 1 equal to? The denominator already cancelled with the denominator LCM out here. So 1 equal to a into these two factors 1 minus x 1 plus x plus b into x into 1 plus x, here it is, c into x into 1 minus x. Now we have a polynomial equation. We want to find out the values of a, b and c for which the polynomial is true. For that, two polynomials can be equal only if the like terms coefficients are equal. Which are the like terms? To know that, let us expand this RHS. 1 minus x into 1 plus x is 1 minus x square. X into 1 plus x is x square plus x square. X into 1 minus x is x minus x square. So the right side is a second degree polynomial, left side is just 1. So what is the coefficient of x square here? Coefficient of x square will be a times x square minus plus b times x square, then minus c times x square. All these coefficients together should be 0 because there is no x square on the LHS. So let us equate the coefficients of like terms on either sides. I have equated the coefficients of x square. No x square on the LHS, so 0. X square here minus a times plus b times minus c times. Here it is minus a plus b plus c equal to 0. Now let me go and equate the coefficients of the x term. There is no x term here. Here bx plus cx. So b plus c will be the coefficient of x on the RHS, but on the LHS again 0. No x. So 0 equal to b plus c. Lastly, let's equate the constant term. Oh, LHS has a constant term 1. RHS has the constant term a into 1 plus what? There is no constant here, no constant here. So only that a into 1 is the constant, which should be equal to 1. That gives me 1 is equal to a. So we have got 3 equations on the 3 unknowns a, b, c, from which we can calculate the values of a, b and c. Okay. Let's see, the value of a is already there, a equal to 1. I'm going to put a equal to 1 in the first equation so that it will become 0 equal to minus 1 plus b minus c. So this minus 1 let me take to the other side and make a new equation. I have plus 1 equal to b minus c. The second equation let me just copy down here, 0 equal to b plus c. Oh, these are two linear equations which I'm going to solve by adding both of them. So 2b equal to 1, so b equal to half. And a equal to 1, b equal to half. By putting b equal to half here, I get c equal to minus b, therefore c equal to minus half. All three values of a, b, c are ready. So let's now rewrite this integrand in the form of three terms. Single term going to be converted into three different terms using this. So here we are. 1 upon x plus, that is a upon x. A is 1. Half upon 1 minus x. B is half. Half upon 1 minus x. Plus minus half upon 1 plus x. Three separate integration. We will be able to do them, integrate them separately, individually. I have taken this coefficients half as a total common factor here. Minus half taken out here. Now think of this integration and here. Oh, what is its integral? Integral of 1 by x. Here we have a direct formula. Integral of 1 by x is log x. So we got the integral of the first term log x. Now second one, half into, what will be the integral here? This is in the form 1 upon ax plus b. Ax plus b, yes, a is minus 1 plus b, b is 1. So whenever the integration is in the form 1 upon ax plus b, it is in the direct form without showing the substitution. We do directly write it as log of denominator but into 1 upon a. So here a is minus 1. So 1 upon minus 1 into log of denominator. That 1 upon minus 1 makes this term now negative. Third one, this also is in the form ax plus b, but a is plus 1, so it doesn't matter, minus half into log of 1 plus x. All three terms integrations over. Now, let me take a coefficient half, common, half, one term, second, third, all three terms. There is no half here. So I may have to multiply here 2. Here we are. This minus makes it minus here. This minus came due to this minus 1 during the integration. So 2 log x is log of x square. N log a equal to log of a raised to the power n. So log of x square minus log of second term minus log of third term. Applying the logarithmic rule, log of x square upon because of these two minus. 1 minus x, 1 plus x with the coefficient here. Now half of log of x square upon 1 minus x into 1 plus x. 1 minus x into 1 plus x is 1 minus x square. Plus c, don't forget to write plus c, constant of integration. Found it useful? Don't forget to subscribe Marie Joseph channel for variety of examples and various topics.